Hello, my name is Justin Razzouq. This is my individual project I decided to make for my EGME 335 class. So here's a four-bar mechanism. You have link 2, link 3, link 4, and then link 1, which is just a fixed put, which is beneath the slider and beneath this pin. You have a pin connection for your fixed and your link 2. You have a pin connection for your link 2 and link 3. And then you have a pin connection in your slider and your link 3. So in this mechanism, we haven't seen a lot of it in the class, but the mechanism, the input is actually the slider. So the slider goes left and right, where I give it velocity and input velocity, it will move left and right, the whole mechanism. So what this is the driver link, the slider driver link. This is the coupler. This is the follower. So the coupler links the follower and the input. And an interesting about this mechanism has two dead points, and a dead point is when the input link can no longer move in that direction, and when the coupler and follower are in the same axis. So I'll demonstrate those right now. I'll pull this all the way this direction, and then I can't go any further this way, or else these two links will just rip apart. So this is, as you can see, they're also in line. They're in a straight line. So if I go back, and there's another dead dead point when you go take it this way, and then you go all the way, the link can no longer move right, because if it moves right it would just rip this pin and it would just send it this way. And also the coupler and the follower, they're in the same plane of motion again, so it just moves left and right like this. Very cool. And then I do have some other points I want to talk about. Okay, here's some other things I wanted to talk about. I wanted to talk about the degree of freedom of this mechanism. So degree of freedom uses this formula. Degree of freedom is how many planes of motion can this mechanism move on. So degree of freedom takes into account your n, which is your number of links, your j1, which is your half joints. So it removes two of the degrees of motion, and then your j2 only removes one, so it's a full joint. So it has 2 degrees of motion. So with this, you can see here there's four links. One is the fix, two is the follower, three is the coupler, four is the input in the driver. So there's four links, so you can put that as your n. And then there is 4J1, so 4 half degrees of freedom, which is usually pins, pin, 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 and then the slider, because it only has 1 degree, which is just linear motion like this, right? So when you put that in the formula, 3 times 4 minus 1, 3 times 3 minus 2 times 4 minus 0 equals 1. So this mechanism has 1 degree of freedom. And then up here, we can I made a vector loop using the mechanism, and what the vector loop does, it it allows you to find velocity and acceleration using velocity analysis and acceleration analysis. Here, I set up the vector loops in the x and y components, and since r4, which is the length of the vector 4, is actually the input, because when I move it left and right, the one thing changing is r4, or the input is r4. So we have to take the derivative with respect to r4, and with that we can get our velocity analysis, and then with another derivative of r4 we can get a acceleration analysis. My name is Justin Razzouq, and thank you for listening and watching my video on my project. Thank you.